Now, as I said at the end of yesterday's lecture, I just wanted to finish off the set of slides on E2E testing, and then I'll let you work on the labs for this week. The labs actually go back to version control or Git related stuff. So I'll talk about those maybe when I've finished the lecture. Right, so let's see. So we're talking about end-to-end testing, and in particular, end-to-end testing of web applications, only because you're doing web app development in parallel with this module. That's the only reason we're focusing in on that. And in that context, we are looking at a end-to-end web application testing framework called Cypress. And I talked my way through this simple little makey up kind of web application that I have on the left there. And I talked my way through the code on the right, which is our first look at Cypress code for testing a web app. And it's all about these Cypress statements. I'll just get my pen out. These Cypress statements, which look like this. And I said that a Cypress statement comprises of a command part and optionally an assertion part. The commands are all about interacting with the browser's DOM data structure. And we know, so just give me 1 second now, because there's a Slack message coming through, and I just want to check to make sure that it's not related to this lecture. Just bear with me for a second. Right. So a Cypress statement comprises of a command part and an optional assertion part. The command part is all about navigating and potentially manipulating the DOM data structure in the browser. In other words, it's about manipulating and navigating the HTML, essentially, that's currently loaded in the browser. So a lot of the commands are about trying to locate a particular DOM element or HTML element. Number one, to see if it's there, is it appearing on the screen? And if it isn't, that's potentially an error or a failure in your test. And you go back and look at the source code to find out why isn't it there. The other reason you might try to access a particular DOM element is because you want to interact with it. An example of interaction would be here, where I'm typing something into a text box. The first part is trying to access the text box, and this is typing into it. Same would be true with buttons or drop-down menus, that kind of idea. This command here, this statement here, begins with a command part where I'm trying to, in this case, it looks like I'm trying to access all the LI elements that are currently being displayed on the screen. And here I'm making an assertion about how many of them are there. So I talked my way through that yesterday. So I just keep on going. So yeah, each statement has a command part and an assertion part. And I talked a little bit about some of the commands that are available to us in Cypress, but there are many others. For many of the commands, you have to specify a selector, and the selector is what allows Cypress to work out which particular DOM elements should it be looking for. I did say that your Cypress tests, they actually run inside the browser. So they have access to the DOM, as well as lots of other things. They have access to your browser's local storage. They have access to the cookies, if cookies are a significant part of a web application, but they run inside the browser anyway. So these selectors, I think that's roughly where I left off. Yeah, these selectors allow, not every Cypress command expects or requires a selector, but some of them do. And the selector can be in different forms. Your selector could be actually an identifier. And if that's the case, it's always a string, by the way. The selector is always a string. But if the string begins with the hash symbol, then that's telling Cypress what follows is an identifier for the particular DOM element that we're asking it to locate. The selector could be CSS. If that's the case, then you've got to begin the selector with a dot character that tells Cypress that what follows is a CSS class, and then it goes looking for all the matching DOM elements that have that class. I also said yesterday that sometimes commands, they don't return one matching DOM element, they may return an array of matching DOM elements, and you've got to be conscious of that in your code. Or you might specify just the tag name of the DOM element or elements that you're looking for. For example, here we're looking for all the button DOM elements currently being displayed on the page. So there's no preceding dot or preceding hash. So it interprets this now to be an actual HTML tag that you're looking for. Or you can specify a combination of any of the above with an attribute. So you're saying here, I'm looking for all the buttons currently being displayed on the page, but only those buttons that have the attribute type set to submit. And so clearly the Cypress runtime can examine the attributes of the various HTML elements that are currently being displayed to narrow down which ones it should try and isolate from this statement. You can also, in some cases, specify where I said there that a command might return a number of matching entries. Well, if you want to pick out one from that array of matching entries, then you can use what I'm calling the ent child selector. For example, I'm giving you a scenario here where the current web page is displaying a table, and it looks like we want to pick out the 8th column of the 3rd row in the table. So here goes my quite long statement now. cy.get tBody, we know, is the HTML tag for a table body. So I'm asking it to find all the table body elements in the current page. Let's assume there's only one. Otherwise, the rest of this statement isn't going to work. So let's assume there's only one. The find then is telling us to pick out all the table row elements within the table body. Remember, find is subordinate to what precedes it. So the find now is going to return an array of matching entries, i.e. all the table rows within my table. The EQ then is the command where I'm passing this ent child selector, if you like, but don't tend to refer to it as a selector. So here's an example of the ent child type selector. And it begins with index 0. So 2 here means I'm picking out the 3rd row or the 3rd element in this array of table rows. So that's going to pick out up to here. Now I've picked out one particular row in my table. And now I'm asking it to find all the table columns within that table row and then pick out the 8th entry in that array of table columns, because it begins with subscript 0. So that's a very good example of a Cypress statement, in that it is using method chaining, which I talked about yesterday. Amongst other things, it's using selectors that are HTML tags in this case. In all cases, I mean, I could have used a mixture of CSS classes here if it was relevant, but it didn't arise. So writing Cypress code is all about familiarizing ourselves with the commands that are available to us. So here we're looking at the get command, the find command, the EQ command. Now, there's a wide range of commands, and we certainly won't have time to use all of them by any means. Really, I think from when we eventually get to work on the Cypress lab, which is next week, you will see a reasonably good range of commands being used in the code that I give you. And I think as long as you pick up all of that and understand all of it, then you would be comfortable enough, I hope, writing your own Cypress tests. All right, let's move on. All right. So we've written our Cypress tests. How do we actually execute them? And we execute them using what Cypress calls a test runner. The first thing I'm saying here is, and I've mentioned it already, is that your Cypress tests, they actually run inside the browser. So when we get to execute our Cypress tests, what it actually does is it kicks off, it opens up a browser tab and runs our tests inside that tab. And I'll demonstrate that in a few minutes. But the tests do run inside the browser. And so they have full access to everything that's available inside the browser tab, like the DOM data structure, the cookies, the local storage, etc., etc. So you've got a lot of power really within Cypress in terms of the kind of stuff you can write for your tests. I'm saying here that Cypress is framework agnostic. It doesn't know anything about React or Angular or any of the other web application frameworks, because Cypress works at the kind of at the DOM level or the HTML level. Doesn't care how that HTML was generated. Flake-free, this was one of the problems with frameworks that preceded Cypress, in that every time you ran the tests, you didn't get a consistent set of results from those other frameworks, whereas Cypress tries to remove all of that. And so it tries to ensure that you get, I'm seeing here, you get a deterministic, repeatable, and consistent set of outcomes every time you run the test. I mean, that's what you want. Every time you run a test, you want to get the exact same result, assuming you haven't changed the test code or the application code. But that wasn't the case in the other frameworks that preceded Cypress. Cypress has certainly improved that situation significantly. And one of the ways it achieves it is, I'm saying here, it reruns a particular part of your test if it happened to fail. So if I go back maybe one or two slides to here, right? If for whatever reason it couldn't find the text box, what it actually does is it delays for a couple of milliseconds and it tries to execute the command again. It looks for the text box again. And the reason Cypress works that way is because it knows that the DOM, if you're working inside a slow browser, it may take the DOM a little bit longer to fully construct the current web page that's being displayed. So it's taking that into account. So it does, once a particular command fails, it'll actually retry it a couple of times. Now, it obviously doesn't keep retrying forever. Eventually, it'll time out. And if after the timeout has expired, and you can actually set the timeout as a configuration setting, but if after the timeout has expired, it still can't find this DOM element, then at that stage, the test will have failed. But it does actually keep retrying a couple of times before that timeout period expires. And so that's the way it tries to ensure that we get the same outcome every time we run our tests. It sort of takes into account the fact that the tests are running inside an environment that that is essentially asynchronous, because that's what's happening inside the browser. All of these things are being constructed asynchronously behind the scenes within the browser, if you like. Don't want to go too much into all of that, but it's just built into the framework anyway. And the whole point of this is to try and ensure that you get the exact same outcome every time you run your tests. That's fine. I'll explain what I mean by time travel when I demonstrate the use of the framework. Okay, so I've written some tests and I want to run them. How do I run them? And there are two ways you can run them. You can run them either in kind of interactive mode or in what's called headless mode. We would run them in interactive mode mainly when we're in development mode, and we would run our tests in headless mode when we are kind of running them remotely. And we'll do that remote running maybe next week or the week after, because we need to cover some other stuff before we can make sense of that. So for now, we're going to run our tests in kind of interactive mode. So if I switch over to VS Code, what I'm showing you here is essentially the Movies app that you are developing in the Web App Dev module. Okay, so if I go into the source folder, for example, let's see. Where's if I go into the source folder, then you should recognize all of this stuff from what you're doing with Roseanne. So we're not looking at the React stuff, but what we are looking is at our Cypress. So in my package.json for this project, I look into package.json, I have added the Cypress library and installed that. And when I ran the tests, when I ran the Cypress command line tool for the first time, and the way I do that is I just type this command here at the command line. And what it does, as I said to you yesterday, is it creates a Cypress folder within our project, and it's in there that we put our Cypress tests. So I have already written some Cypress tests. So if I go into my Cypress folder, and there's a subfolder within that called the E2E folder, that's where we put our Cypress test files, or specs as it calls them. And I've got 3 at the moment. And it looks like I've got, in this file here, I've got tests that examine the favorites functionality within my Movies app. Here, it looks like I've got tests that check the workings of the filtering functionality. And up here, I've just got some basic tests to check that, well, the app does actually load in the browser and the home page loads I'm not checking for any functionality as such. It's just some very basic tests, if you like. So I've written those 3 tests. And if I now start up my React development server, so down the bottom right here, I'm going to type npm start. So that's just starting the React development server, as we know. And it fires up a browser tab. Now I can actually shut down this browser tab. My Cypress is going to open up its own browser tab. So I'll just close that off. But my development server is still running behind the scenes, and that's important. Now I'm going to open up a second terminal within VS Code, and the way you do that is you click the plus symbol here. So if I start up a second terminal, and I need to cd down into the movies subfolder. And now I'm going to start up the Cypress graphical user interface tool, which is this kind of interactive mode that I'm talking about. And the way I do that is npx Now this command works because I have installed the Cypress package as part of this project. Otherwise, it would not work. And it's npx and not npm. So if I hit return, here's the Cypress GUI. And it's asking me, am I doing end-to-end testing or component testing? We won't be looking at component testing. So we'll select end-to-end testing. It's asking me, do I want to run my tests in a Chrome browser or in an Electron browser? Electron would be if we were developing native apps using React, which is something you can do. So I'll select Chrome. And when I click the start E2E testing, if this was the very first time that I ran the Cypress tool within my project, then that would cause it to go away and create the Cypress folder and create these subfolders within it. Okay, they'd be empty initially. But this is not the first time that I'm running this command within this project. So in that case, what it does is it actually goes looking for the E2E folder and see are there any files in there. And so if I select start here, it has discovered now there are 3, as Cypress calls it, there are 3 specs within my E2E folder. And if I click on any one of these, it's going to run that test. So let's say if I look at the favorites test. Okay, so I've got, some describe blocks and before blocks and it blocks and all of that kind of stuff. I'll look at the detail in a few seconds. But for now, I'm just going to run it. Oh yeah, when I clicked start there a moment ago, what Cypress actually did was it opened up a new browser, Chrome browser instance for me. You can see here I've got 2 Chrome browser applications, or 2 instances of the application running. One of them was one that I started myself. The other one is an instance of the Chrome browser that Cypress has started. I don't know which is which here, but I'll just, okay, this is the one that I'm looking for. So this is a running of the Chrome browser, which Cypress started for me. And it loaded the Chrome browser with its own kind of page, if you like. And that's what I'm looking at here. But when I click one of these here, one of my test specs, then it's going to run that test inside this browser tab. And so let's just do it. If I click the favorites one, and it's running through the test. And you can see obviously that it's loading my Movies app, and it's going through selecting favorites, and it looks like it has navigated to the favorites page, and I can see the favorites page here with 2 movies selected. Okay, but all of this was actually controlled by the test code that I wrote for my Movies app. And if I rerun the test, which I can by just clicking this here, it'll rerun it all over again. Right, so where are we? Let's see. So that's running the Cypress in interactive mode as opposed to headless mode. We'll talk about the headless mode maybe later on. When you run a test, then we talk about getting red bar or green bar as the outcome. And if I go back to my case, we got green bar here. Green bar means that all of your tests ran successfully. If one of them fails, then you get a red bar here, and then you start looking at the essentially kind of an audit trail of every step in my tests, because these can be expanded. Okay, and what I'm actually looking at here is the actual Cypress commands within my it block of one of my tests, and I can find where exactly it failed. Didn't in this case. So the outcome of running any of your tests in interactive mode is you get this green bar or red bar outcome, and obviously you're looking for green bar. I said that maybe I can look at the code at this stage. Let's just do that. Let's see. Maybe not. Let's see now if I go back to here. So I expanded one of my tests. This over a little bit. And we can see here, look, it ran a get command. So that there's obviously a get command within one of the tests here, and it's the get looks like it returned an array of matching entries, and here I'm picking out one particular entry. I think the get command is actually getting all of the movies currently displayed on the home page, and then I'm picking out one particular card, if you like, and within that card it looks like, I think from memory anyway, I'm looking for a particular scalar vector graphic, which might be my favorites, this kind of favorites icon down here, so that I can click on it. So I'm let's see, let's pick up maybe this one, might be a slightly better one. Yeah, I mean, I'll show you the code in a few minutes, but what's going on here is what I was saying there, that I'm going through, I'm picking out one particular movie on the home page. I'm looking for the heart symbol at the bottom left-hand corner, and I'm eventually clicking it to which simulates selecting that movie as my favorite, and so on. And then am I selecting a second one? Maybe I'm selecting a second one. But if I click on any one of these, then it'll bring me back to that particular point in the execution of my test. and I can see what the state of the UI was when it got to that stage in the test execution. This is what you would typically do when you're trying to debug an error in your tests. So I'll come back to that, and that's what I mean by time travel. You can step backwards and forwards through each command in the sequence of commands that make up a particular test, a particular Cypress test. And if you click on the command, then you see exactly what the state of the UI was at that point during the execution of the test. Might come back to that a little bit later on. Now, eventually we have to actually write our Cypress tests, and a lot of your time will be spent trying to express in Cypress commands the particular DOM element that you want the Cypress test to pick out and maybe manipulate, or to pick out and do some make some assertion about the DOM element. So trying to work out how do I express the selector for picking out the DOM element, and it will all be about looking at the actual HTML that's generated for the particular page that you're testing. So, and I'm just giving you a screenshot here, but maybe if I show you what I mean by that now. Let's go back to, now I closed off the browser. So if I open up my browser tab at localhost 3000, so I'm now back in my own browser tab here. This is not Cypress's one now. And let's supposing I want in my Cypress code to be able to pick out the heart symbol. How do I find express the selector for that? Because a lot of the HTML that's generated for this app is actually generated by React, and in particular, it's the Material UI CSS library that you are using with React. So that Material UI library is generating a lot of the HTML for us. And so we do need to look at the raw HTML to try and work out what did Material UI actually generate in terms of raw HTML to produce this icon here. And the way we do that is we use the dev tools that are built into Chrome. So if I open up my dev tools, and you may be familiar with this already, if I select the Elements tab, which happens to be selected already, we have the Console tab and the Networks tab. So select the Elements tab, and if I click this icon here, as I mouse over parts of the screen, let's say I just select here, okay, I mouse over that, and if I click it on the right, it'll take me to the exact point in the raw HTML corresponding to whatever I've moused over. So if I click that, so it looks like it's a path element, and that path element is contained within a button element. And here's the CSS classes, and there are Material UI CSS classes that are attached to that button element. So they may be useful to me to express the selector that I will pass to my Cypress command in order to pick out, the particular DOM element that I'm trying to pick out. If I let's say I want to, let's say if I click that, and in my CSS, in my Cypress code, I want to be able to pick out this icon here. So in the same kind of vein, I will select this first and then mouse over it, click it, and it brings me directly to the HTML code. So that's looks like it's a div, but if I expand the div, it has an SVG, so it's the scalar vector graphic. That's really what's producing the heart icon backlit in red, and we can see the actual CSS classes that Material UI has attached to both the SVG element and the containing div element, and so on and so forth. So you will find yourself following this kind of process when you come to writing your own Cypress tests, because you need to know what exactly is the raw HTML associated with the particular part of the web page that I want my Cypress code to kind of pick out and either check that it's there or manipulate it. Manipulate it might be clicking it, typing something into it, so on and so forth. So if I go back to the actual test that I wrote and look at the favorites test, because that's the code that we looked at. So here we are in the favorites. By the way, these Cypress test files, their extension by convention is .cy.js. So if we just look at a little bit in detail at this Cypress test, I'm going to skip over the before block and the before each. Well, before each is straightforward enough. I visit the home page, and the home page we know is the page that displays our 20 movies. So that's going to run before each subsequent it block that I have down here. And that makes sense. I want to go back to the home page every time before each test. So I've got a test here, and it looks like it's about just checking that the selecting of the favorites actually works. And so how would I prove that selecting the favorites works? Well, if I click the favorites icon on the bottom left of a card, then the heart icon should appear on the top left. Yeah, that's how I might express my test in English. How do I express that in Cypress code? So I've got a statement here, and the purpose of this statement, well, the purpose of this one is to check, let's say, in the very first movie in my 20 movies that are being displayed. Well, I'm picking the second one, actually. It's index 1, so that's the second one. I'm just arbitrarily picking the second movie, and I'm checking to see that the heart on the top left of the card is not there. In this statement, what I'm doing is I'm finding the heart symbol in the bottom left of the second movie card, and I'm clicking it. So let's take this statement. How did I come up with this statement? It begins with a get, and I'm passing it I'm asking Cypress to find a button tag that has this. Sorry, no, let's just undo that. Find the button that has an attribute called ARIA label set to add to favorites. Now, how the heck did I come up with that? Well, let's see. If I go back to here, back to here. So I need a way of identifying these in my HTML. So let's just do that again. And it's the same for all of the cards. So I'll just pick one of the cards. Okay, so it's picked out this tag here, but if I look around it, obviously it's a button. And so if I look up a little bit, I can see that I've got a button here. And when I examine it in terms of its attributes, I find that the button, can I find the, let's see, if I go over here, I mean, I could have picked any of the attributes, but I noticed this attribute here, ARIA label, and it's set to add to favorites. So I've just arbitrarily decided the combination of button and this particular attribute that will uniquely pick out, it won't pick out a particular heart, it'll pick out all of the hearts of all of the cards that are being displayed. So see why that gets this bit here. It's going to pick out the 20 heart buttons that are currently being displayed on the home page, and arbitrarily picking out the second one. That's going to be of the second movie, and I'm clicking it. The purpose of this statement now is to check that that same card has the heart appearing on the top left. So I need a way of expressing the selector for that particular heart. So how do I discover that? In this case, it looks like I've just decided I'm going to use the CSS class of that DOM element as a way of selecting it. And really, it's a matter of choice, really. There isn't a right way and a wrong way. But just to confirm that that actually works in terms of selecting it, if I just select any movie here, I've got one selected already. And again, go through the process of examining the raw HTML. Okay, it's an SVG. I could have picked the pat element. I picked the parent element. Is that what I did? In fact, no, I took the CSS class. Let's see, what did I do in the code? I'm saying pick out MUI card header root. My header root. All right. So pick out all the elements that have that CSS class. Take the second one, because there's going to be more than one match. There's going to be 20, as we know. And within the one that I've selected, I'm saying within that element, so this has picked out, this expression here has narrowed it down to one DOM element, but I want to look inside that element for a sub-element of type SVG. So what am I doing there? Let's see. I think what I'm doing is I'm picking out a lot of these MUI, material UI classes are similar. So MUI card header root, and where that is, it's one of the divs up around here. You see a lot of the MUI classes are quite similar, so it's one of these divs anyway. I could have picked any of them, but it's one of these divs. And once I've picked out one of the divs, then within that, I am specifically looking for a subordinate scalar vector graphic element within that. And they all have that, as we can see here. So that will have picked out this scalar vector graphic. If, of course, the heart actually is appearing on the card. And that would only be the case if the clicking of the button down here worked, essentially. And that's kind of what we're testing. Does that functionality work? So it can be mainly because of Material UI, because that generates, we can see here that Material UI generates an awful lot of HTML, and it's kind of nesting divs within divs. And it doesn't really matter which level of div that you pick for this particular scenario. Just pick one of them. And I think the CSS class seems to be the best way when you're using Material UI. The CSS class is the best type of selector to be using for many of them anyway. So it's a slow enough process, admittedly, but hopefully there will be enough examples in the code that I give you. So this entire expression eventually picks out the presence of the heart in the top left corner of the second card in my home page, because I clicked the heart symbol of the second card in this statement here. And all I'm doing here is checking, is it there? And if it is, if the heart is in the top left corner, then I know that functionality is working. Because if you compare the line that I've highlighted here with this line, this is actually looking for the exact same element, but I've added an assertion on to the end of it. And the assertion is saying, essentially, that element should not exist. It should not find it. And not finding it is success in this case. That makes sense. It shouldn't be here now, but it should be present at this stage because of what I've done here. Right. The second test, what the second test is doing is I've got a before each block here, and essentially what I'm doing here is I'm selecting just arbitrarily 2 movies on the home page as favorites. It looks like I've selected, let's see, I've selected the second one and the fourth one as favorites. And then I navigate to, I don't navigate. What I'm doing here is I'm looking for, bear with me. I'm looking for this anchor tag here in the top left. I'm looking for the anchor tag. And again, having examined the HTML, although it's fairly easy because there aren't many anchor tags. In fact, there's only one anchor tag with favorite as its text. And that's what I'm expressing here. Get the anchor tag that contains favorite as its text and click it. Now that action, if you like, that action in the browser is going to cause my browser to navigate to the favorites page. So I want to do that before each test, although I've only got one test, I think. Yeah, I've only got one test, but I put it into the before each block. And inside the it block, so this code here now is going to, this is going to execute in the context of the favorites page currently being displayed on the browser. And what I'm doing here is, yet again, I'm checking to see, because I've selected 2 movies here as my favorites, there should be 2 cards that appear on the favorites page, and that's what I'm doing there. And here, now, are they the right two cards though? In other words, the way we might determine whether they're the correct two cards or not is by the movie title. But how do I know what the titles of the movies that I've selected up here are? And the answer to that brings me back to here in the before block. In the before block, and this is a feature that's, I wouldn't say unique, but it's particular to our movies app. What I'm doing here is I'm just making a HTTP request to TMDB for the same 20 movies that my React app is requesting. So that's just, that's using Cypress to make an ordinary HTTP request across the web, which Cypress supports. Okay, so it's not commands and assertions in the traditional sense. This is just standard HTTP requesting. So I'm requesting the same 20 movies that my React app requested, and I'm storing them locally, as in I'm storing them up here. And having those 20 movies, that allows me to find the titles of them if I need to. And I do need to, because I use them. Let's see. I use them here. Essentially, what I'm doing here is I'm finding the movie title in the movie card of my favorites page. And again, you know, I've worked out that this particular CSS class, this will pick out the this picks out the titled part of all of the cards on the favorites page. I'm picking out the first one. I'm finding a paragraph within that part that I've selected up here. Now, how did I know that the title is actually in a paragraph tag? Try this once more. If we go back to here, we don't actually have to go into the favorites page, but just reduce the size of that a little bit. So I'm saying the movie titles. Let's try and find them in the HTML. You can see there that the movie title is represented in a paragraph tag. And again, that was generated by Material UI as well. So I find the title of the first card on the favorites page, and I compare it to movie titles subscript 3. Movie titles subscript 3. What? Why 3? Sorry. Let's take this one, which is the exact same. And comparing it to movie title subscript 1. And here, movie title subscript 3. Why 1 and 3? Well, if I look at the movies that I clicked up here, I clicked subscript 3 and these two here, sorry. I clicked subscript 1 and 3, but let's just check that now again. Oh yeah, it's just the array indexing starting at zero idea. So the array of movies that I've retrieved from TMDB up here, I'm just digging into those and looking at the titles of those movies and comparing them to the titles that are appearing on the cards in my favorites page for this particular scenario. So for sure, it can be quite slow coming up with this code initially, because you're doing a lot of back and forth between here and here, trying to pick out the appropriate selector for your Cypress code. So that can be quite painstaking initially, admittedly. Right. That's what I'm trying to get across in this slide, that this is the process you have to go through in order to choose the appropriate selector. And there isn't a right selector or a wrong selector. You're just, whatever works for you, that's fine. And just to go back in terms of that time travel thing that I was talking about, if I go back to the browser tab now that Cypress is controlling, and if I pick out that part of the test that I was just showing you there, let's see. I'll collapse this first. So the favorites page is the one that I was stepping through there. And if I expand, so here I am in my before each part where I just select 2 movies. So if I just click this here on the right, I'm on the home page, and I am, see, I'm picking out all of the hearts on the bottom left of each card. I'm picking out arbitrarily EQ1. So if I just click and see what part of the page has been selected. Now, if you look at this heart here compared to this one is backlit in gray, and that's telling me that this is the point of the browser screen that is currently being focused on by Cypress, because I just clicked on this line here. This is this time travel thing. If I click on this line here, I'm taking Cypress back to the point, to this particular point in the test code. And where is Cypress currently focusing on at this particular point in time? And by examining, now it is a bit sensitive, so let's go back again. Okay, it's telling me Cypress is currently picked out this particular DOM element. And if I go just immediately after it, if I just scroll up on that card, okay, so this card hasn't been selected yet because the click hasn't been executed. So if I click the next line after that, and I go back to my card, now we can see the heart symbol is there. Again, if I go back to just before clicking, okay, there's no heart symbol appearing just after clicking. and it's there. And so, you know, I can do that, step my way through, if I mainly as a debugging technique. So that's this idea of time travel. Now, I am running Cypress there in interactive mode, in headless mode. This is the command, it's npx cypress run, and that simply runs all of the tests from beginning to end and just shows you the outcome in the terminal. It doesn't, you don't see any browser tabs opening up or anything like that. That's fine. So it runs all the tests. You can actually get it to generate a video recording of the execution of the tests if you need to. The reason you might want to do that is to share them with other team members. Doesn't arise in our case though. Also, this headless mode is extremely useful when you start looking at the area of continuous integration, CI/CD, which is the next topic that I'm actually going to look at possibly next week. Essentially, CI/CD would be where you want to run your tests in a remote server. But if you're running them in a remote server, there's no screen as such associated with the remote server, so you don't have any browser that you can start up and look at or see a visual representation of. So how do I run my Cypress tests on a remote server that doesn't have any screen as such? And that's where this headless mode of executing your tests come into focus. There's also an online service accompanying Cypress, and if I flick over to just my ordinary browser instance, keep mixing up which is which here now, but if I just open up the browser tab and go to cypress.io, you can register for an account there. I've done it already, so if I just log in, once you've registered, you can pick any login service you want to. I'm using GitHub. And the point here is that you can link your applications, which presumably you're hosting on GitHub. You can link a GitHub repo with a project in this Cypress cloud service. And the idea is that you would run your Cypress tests in a remote server using this continuous integration process, and then publish the outcome of those test executions, publish them here in your Cypress IO account, and share that with other members of the team working on the same project. That's kind of the thinking behind having a cloud service accompanying all of this. And you may well get to do that in the first assignment that I give you. I won't do it in the labs though, but it's pretty straightforward. How does Cypress actually execute a test? Well, it doesn't simply run this line first, then this line, then all of these things. It doesn't run them as it sees them in the sequence of code. What it actually does is, and the reason it takes this approach is because they're running inside a browser, and a browser is an asynchronous execution environment. You know, and I was talking about that earlier on, you know, that the idea that it takes the browser a period of time before it fully constructs the current web page that it wants to display. So all of that kind of asynchronicity needs to be accounted for by your tests. but hopefully you don't have to account for it. The actual framework accounts for it. So for example, if you take here where I do cy.visit localhost 3000, now behind the scenes, what that's doing is it sends a request to your development server, and the development server responds back with the HTML, CSS, images, all that kind of stuff. Now, the browser then takes all of those assets and constructs the page, and all of that is time consuming. So Cypress can't straight away go executing this command because maybe the browser is still constructing the page. And I was talking about that earlier on. So what Cypress actually does when it wants to run this code is it actually builds up a queue of the commands. It enqueues them. So it constructs this queue itself. So that means it has to actually read through all of this code to construct this queue. And then it goes back to the start of the queue and it executes the commands at that stage. But it doesn't execute them and then go on to the next one and on to the next one. It will execute a command. So for example, the get here is looking for the text box on the screen. If the command responds with a failure, as in it can't find the text box, it doesn't exit straight away. It'll actually retry. It'll wait for a period of time and retry the command again. And I was talking about that earlier on. And the reason it's doing that is because it's potentially waiting for the browser to fully complete the construction of the web page and for the various elements on the web page to be active, if you like. So it goes through each of these commands in the queue, executes them, and if they fail, it'll wait a little period of time and try them again, and eventually it will give up. It will time out. So this kind of loop here, this retry idea, is repeated for every one. So that's how it actually works behind the scenes. We don't necessarily have to be aware of that, but it's good to know, I guess. And that's how Cypress kind of gives you this deterministic, repeatable, consistent outcome every time it executes the tests, even though there's a lot of asynchronous stuff going on behind the scenes within the browser and within your application. And all I'm saying here now is just I'm kind of documenting, if you like, exactly what I was talking about there a few moments ago. So you can read through that yourselves. I mentioned that the programming style is very much based on this meta chaining style. And so just to add to that, here we've got some meta chaining going on. So we're looking for a H4 element. We haven't seen the next command, but that's just another command. What next we'll do is once Cypress has found the H4 element, and let's assume there's only one, because if there isn't, then the rest of this won't actually work. It'll throw an error. But let's assume there's only one. Then what next does is it goes to the next sibling DOM element after the H4. So that's how, for whatever reason, that's how I've decided to express what I'm looking for here. But in terms of meta chaining, so each of these commands returns what Cypress calls a subject. And the subject then becomes the thing that the next command operates on. So cy.getH4, that returns a subject, which is just an object, really, Cypress object. And the next command operates operates on that object, if you like. Equally, next returns a subject, and the next command operates on that subject. So that's what's happening behind the scenes. Sometimes the subject is an array, and I've mentioned that before. But so that's just the language we talk about as this example here, actually. let's assume that cy.getLi finds a number of matching li elements. So we've got an array of them. So the array is the subject of the first part of this chain, and the equals then operates on that particular array. The array is the subject in that case. So each command yields a subject to the next one in the chain. Sometimes you may actually want to grab that subject object and do some processing of it. And you can do that by using the then method. So this is very like the promises programming model that you might have come across in web app development. So what am I doing here? I'm looking for all the divs in the current page. I'm picking out the third one in the array. And within that div, I'm looking for a button. Now, I want to do some processing of that button for whatever reason, right? So the way I do that then is that I chain on the then method. I don't think you'd call it a command really. That method, and then takes a callback. So this here is our callback function, and button element will be bound to the button DOM element that has been isolated here, and I'm just doing some processing of it. It looks like I'm trying to pick out the CSS classes of that DOM element. Maybe I want to make some assertions about the CSS classes. So you can do that. It's rare, but there are a few edge cases where you might actually want to use this then method to process a particular DOM element within your test code. There may be one or two cases of that in the test that I give you. Cypress is asynchronous. We've said that a number of times. This is kind of, let's supposing I've got this web page and it displays boxes, okay? And let's not worry about what's inside a box now, but it displays boxes. And initially, it displays 20 boxes, and there's also a button on this page. And if I click the button, that's going to add another box to this page. Okay, so that's my scenario. And I've written a test to check that the clicking of the button will actually cause another box to be added to the page. So that's just a little bit of functionality that I want to test. So here I've written my tests, and it looks sensible enough. I've got just a local variable called numBoxes, initialize it to 0. Then I've got, let's say I've got a CSS class called box, and I'm looking for all the elements that have that box CSS class. And so that's going to return an array. That's the subject in this case. It's is a command that allows you to examine the subject that it's operating on. Now, my subject in this case is an array. And so with the its command, I can actually check what the length of the array is by using this argument, okay? And then I'm using my then that I was talking about a moment ago. And it looks like what I'm doing is I'm setting num boxes to whatever len is. So you'd imagine num boxes is now going to be 20. I've initialized it to 0. Now it's going to be 20 here. Then I go away and find my button and I click it. So that should have added a box. And I do the same thing here. I check to see how many DOM elements with the CSS class .box are there now on the screen. And the length should be equal to numBoxes plus 1. Yeah, that makes sense. But it doesn't work though. And it doesn't work because of the whole enqueuing and asynchronous nature of how Cypress works behind the scenes. For this particular scenario, this stuff here is kind of subordinate to what preceded it. And the way I would write this code, I know now this is quite advanced stuff, so just bear with me. This is the way I would need to write it. Okay. I'd need to put the subordinate code, the code that involves clicking the button and now checking how many boxes. I actually want that to be delayed until I'm absolutely certain that this did actually find my 20 boxes at the very beginning. It's as I said, it's a fairly fine grain point. Let's see whether it get boxes. It's linked. Yeah, so you can see I've just put all of this code inside a then clause rather than having it as a purely sequential sequence of commands. I don't think that arises really in any of the tests that I give you, but if you do see it, then that's the rationale behind it. As I said, it's quite an advanced point. And in fact, it's the last point, right? So the majority of your time writing Cypress tests will kind of be around examining the HTML and trying to pick out appropriate selectors for your commands in order to pick out particular DOM elements. And sometimes a test is only concerned with establishing whether a DOM element is on the screen or not. And if it is, that's success. On other occasions, you may want to make assertions about the DOM element. So that was what I really started this lecture talking about, that each statement comprises of a command and an optional assertion. The command is nearly always about find a particular DOM element on the browser page, on the current page, and the assertion that is about making some assertion about it. So in next week's lab, you will essentially be writing these tests for the, I'll be giving you the code for the Movies app. So, hopefully it'll make a little bit more sense, all of this stuff, once you start practicing it. For this week, though, in terms of labs, if I go over to Moodle, let's just close off Cypress now because I'm confused as to which of these browsers is which. So if I kill the Cypress GUI, now I'm just back to one browser tab. So for this week, there are 2 labs. Let's find the lab section. So there's this lab here, which is the branch edit merge that I was talking about a little bit yesterday and mainly last week. And you need to submit that. The second lab is all about GitHub pull requests. And if I just give you a brief context for the second lab, the first one is straightforward enough. I've talked a lot about that. So the context for this second lab is, let's suppose we've got a team of software engineers working on a project, and one member of the team is the team leader, and the others, we call them contributors to the project code base. And we want to use Git and GitHub for managing our source code. So what happens in industry is the team leader would create a repo in the team leader's GitHub account. And that's going to be the main account for hosting all of the source code. Now, rather than giving other team members access to that repo, instead we follow what's called the fork and merge process. And the way that works is the other team members, they create a fork or a copy of the team leader's repo. And GitHub has a way of allowing you to do that. It's just a button you click to say that you want to create a fork. And when you create a fork, what GitHub does is it makes a copy of the team leader's repo and puts the copy into your GitHub account. You can now clone that repo and you can make some contributions to it. You can update it because maybe the team leader would have added some code to the repo after creating it. So you can update your copy from the masters, from the team leader's copy, but you can add code. You've cloned your own copy of the repo now, cloned it onto your own local machine. The team leader, let's say, gives you a task that he or she wants you to carry out, implement a feature, fix a bug, whatever. You do that development work on your local machine. You then push that to your copy of the repo, and then you issue what's called a pull request, which is a kind of a form that you fill out, and it's all kind of built into GitHub. The lab steps you through it. And essentially a pull request is a request from your account to the team leader's account to have the code that you have written, the team member has written, to have it merged into the team leader's repo, and more than likely into the master branch of the team leader's repo. So it's this fork and merge, it's a process to facilitate teamwork, all built around source code development using GitHub as kind of the backbone for managing the source code. So the lab, in order to do this second lab, you have to just work with another classmate, because it has to be one member of that two-member team. One will just be the team leader, the other will be the contributor, and the lab steps you through, again, using the catalog, the little catalog project as our Maria project that's being developed. Steps you through this whole process of forking and issuing pull requests. And then you reverse roles and you repeat the lab where the person that was the contributor now becomes a team leader and goes through it all again. So it's important that you just get at least one experience of this whole fork and merge and pull requests idea, because it's very commonly used in industry. So I guess you should start with this lab here, because you do need to submit that by tomorrow afternoon, admittedly, so you've got some time. And then you should work with a classmate on this lab. Okay, that was a long lecture now, admittedly, but I'm going to, unless there are any questions now, I'm going to actually stop this meeting and let the recording, I'll upload the recording onto Moodle as usual. So I'll just pause for a second in case there are any questions. No, okay.
When is the fork merge workflow thing due?
You don't have to submit that.
Oh, okay.
Yeah, but I would strongly advise you to work through it with a classmate, though, because it does actually come into the assignment. That's that's the catch. So you will have to know how to set up and complete a pull request, essentially. So this steps you through it. So you get the experience here, and you have to repeat that in the assignment. I'll talk about the first assignment to you next week. But to answer your question, you're not submitting it. Anything else? So I'm going to remain online, and any questions that you have, just contact me on Slack, and if we need to, I'll just kick off another Zoom meeting and we can deal with the issues there. Okay, thanks for hanging in there, and I'll be in touch with you.